Okay, this is John Marsh. I'm here doing some homework problems for NCS 450, 541, and I'm on homework number 2, problem 2. And problem 2 says, suppose a class C network is broken into /28 subnets. How many are there? Calculate the total number of host addresses available. I'm also going to calculate the number of host addresses per subnet. At the same time, and then same two questions except start with a class B network. Okay, and in almost all my videos so far on the subject, including the introductory ones, we've started with a class C, and so this will be a little bit different, starting with a class B. So we start with a class C. So we start with a class C network, and we have /28 subnets. Okay, well, let's always start with our network subnet host picture, where n plus s plus h is 32 bits, and I have a /n plus s as my designator. Okay, so in other words, in order to get the number of bits that are used to identify hosts, we have to take 32 minus the slash number, because 32 is h plus n plus s. So h is 32 minus 28, which is 4. So we have 4 bits for host addresses. And so that implies that the number of IP addresses, I'll call them IPs, is equal to 2 to the h, which is 2 to the 4th, which is 16 IP addresses. Okay. The number of usable IP, the number of usable host addresses is 2 less than that due to the network ID and the subnet broadcast, and that's 2 to the h minus 2, which is 16 minus 2, or 14 addresses. Okay, so that's the number of host addresses. Let's see, how many subnets are there? Well, we started with a class C, so the n was 24. And when n is 24, we have h is 4, then s is 4, right? S plus h has to equal 8, because n is 32, or n is 24. So s is 4, and that means that there are the number of subnets is equal to 2 to the s, which is 2 to the 4th, which is 16. Okay, so I've calculated this maybe in a funny order, but basically I've calculated the number of IP addresses and the number of subnets. Number of subnets, number of IP addresses per subnet, and number of host addresses is 2 less than the number of IP addresses. Okay, so this answers A and B. Oh, B also wants the total number of host addresses. Total number of host addresses is the number of subnets times the number of host addresses per subnet, which is 16 times 14, which is 224, I believe. Yeah. Okay, so that answers parts A and B. Okay. The same question, now C says the same question, but start with a class B network. Okay, now this is a little bit different. We're going to start with a class B. In other words, n is going to be 16. Okay, and so if we use /28, that implies that n plus s is 28. And that, n plus s is 28. and that implies that H is 32 minus 28, which is 4. And we also have S is equal to 28 minus N. 28 minus N, which is 28 minus 16, which is 12. Okay? So N plus S plus H add up to 32, like they oughta. And so I can say that the number of subnets is 2 to the S, 2 to the 12th, or 4096. The number of hosts per subnet is 2 to the H minus 2, which is 2 to the 4th, minus 2, which is 16 minus 2, which is 14. Okay, and if I want to calculate, and so that's basically the calculation going on here. If I want to calculate the total number of hosts, I'm running out of room here. Let me go ahead and put it over here for part C. Total number of hosts is equal to the number of subnets, 4,096 times 14 per, is equal to 4096. Is it really 4096? Yeah, that's 2 to the 12th times 14, which is 57,344. As you can see, Class B's are big. Okay. Okay, so this is problem 2. Hopefully that's a fairly straightforward exercise. Hope that helps.